Hello guys, welcome to my channel. So in this video we are going to learn about ReentrantLock and ReadWriteLock. So before learning about ReentrantLock and ReadWriteLock, let's go to the IntelliJ. So I think in the last video we are facing some issues with this then apply method, right? We are not able to get the output. And what output we are getting is, let's try to run this code. Yeah, this is the output we are getting this. Guys, actually what is the problem? I'll tell you. So I am trying to print here that res variable, right? So that res variable is returning as the completable future object, not the actual integer. That's why we are getting this out. This is the output. So if you want to, I told you, right? If you want to get the result from the future object, you need to use some method called as get. So when you use get method, so then you can get this output. So let's wait. Yeah, you got the where you are passing supply async as 10, and after passing that, then you are then apply, it will transform the result of the previous task. So I am doing 10 into 2. 10 into 2 is 20. So you got the output. So this is the issue. Like yeah, it's a simple thing. We need to call the get method. So now let's come to retrant and read light lock. So in Java, we have seen the synchronized keyword, right? So, but synchronized keyword has some limitations. And in order to overcome those limitations, Java provides another way to lock the resources with the help of ReentrantLock. So we will see how we can lock the resources, what are all the methods that are available in the ReentrantLock. So everything we will see. And also there is one another thing called as a read write lock. When your application has many readers but very few writers, then Java provides something known as read write lock for better performance. So let's see one by one. So let's look at what is a read lock. So what is ReentrantLock? So ReentrantLock is an alternative to synchronized, but it provides explicit locking and gives more features than synchronized. So it provides more control over the locking things. That's why we are going for ReentrantLock. So I'll give you one simple real-time example. So when you think of synchronized, think of it as like an automatic door lock. So when you enter the room, the door will lock automatically, and when you leave the room, the door unlocks automatically. So it's very simple, straightforward. Like as a user, you don't have much control over this. So synchronized keyword will take care of everything, locking and unlocking. But on the other hand, if you come to this ReentrantLock, it's like a smart digital lock. That means you decide when to lock the resources and you decide when to unlock. And you can even try to lock it for a few seconds and give up if the resource is already locked. But so that's what we are telling. Like this ReentrantLock will give you more flexibility to lock the resources. So let's uh, see why we use the ReentrantLock. So the because of the advanced features that it is giving, we are using ReentrantLock. So what are the advanced features? So the features is tryLock and lock interruptably, fair lock, and better control over locking. These features are not available in the synchronized. That's why we are using this ReentrantLock. So let's see one program. So this is the program that I have written it for you. So there is a private count variable, initial value is 0, and I am creating the object of ReentrantLock, and we have an like instance method called as increment, and in that I am calling lock. That means it will lock the resources. The thread will lock the resources. And in the try block, what I am doing is I am incrementing the count by calling count plus plus, and I am printing the thread like thread dot current thread dot get name, and I am printing the count, like it will print the thread name colon count, and I am unlocking it in the finally block. Why I am unlocking it in the finally block is, even when the exception occurs, the finally block will be executed and you will be unlocking the resources. That's why you should unlock in the finally block. So now we will try to call this method with the help of two threads. So in the main method, I am creating an object of return this one return log demo, because these are all instance method. In order to call this, I need to create an object. So in order to call this increment method, I am creating a thread. So how do I create a thread? Thread t1 is equal to new thread, and this is the run method. I am overriding it, like you can see. This is a run method with the help of lambda expression. I am doing it. I am calling it in a for loop. That loop runs for 5 times, and I am calling demo.increment. So what happens is, there is a thread 1. This thread 1 is calling this increment method 5 times. So that is the that is how this method works. And in the double quotes, I have this thread 1. That means it will print the name of the thread. Here I am getting get name, right? It will give thread 0. Instead of that, I am printing it as thread 1. The same way I am calling with the increment method with the help of thread 2, and I am running it for 5 times. After that, I am both starting the threads, because if you create a thread t2 is equal to new thread, the thread will be created and it will be new state, but it's not yet started. So in order to start a thread, what you can do, you need to call this t1.start and t2.start. After that, t1.join and t2.join. Like once t1 has to wait until completing t2, so we are calling the t1.join and t2, and main thread has to wait until the t1 and t2 finishes. That's why I'm calling this t1.join and t2.join, and finally the program is finished. So let's try to execute this code. It should print like thread 1 thread 1 2, like that. So you can see it here, thread 1 1 thread 1 is calling that method 5 times, right? So I need to, in the thread 1 I am getting 1 2 3 4 5 thread 1, and after that thread 2, second time thread 2 is executing that method. So thread 2 6 7 8 9 10. So what happens is, in the first time, when thread 1 is calling the demo.increment method, so it will call this method and it will lock this method, and it will keep on executing. When thread 2 tries to execute that method, the lock is not available. So that's why thread 2 will be in waiting state. Once the thread 1 releases the lock using lock.unlock method, the thread 2 will be executing this increment method. That's why you can see the output thread 2 will start from 6. Okay. So after that, thread 1 only, thread 2 will start. So this is the example for ReentrantLock. I think you understood what is ReentrantLock. Now let's try to understand with some real-time example. So imagine there is an ATM machine, and as you all know that at a time only one customer should withdraw the money in the ATM, right? So before withdrawing, what this customer or the person will do means, he'll lock the ATM and he'll withdraw the money. And once the transaction is done, he will unlock the ATM and he'll go out, so that the next customer can use the ATM. So this is how the ReentrantLock works. Like, it will lock the resources, and so that the one thread can execute the method. When it's done, it will unlock the resources so that the other thread can use it. In synchronized, it happens automatically, but here in ReentrantLock, like as a user, you are responsible to lock and unlock the resources. So when you should use ReentrantLock means, when you want to have advanced locking features like tryLock, timeout, fairness, or interrupted locking, you can try this ReentrantLock. So now let's talk about ReadWriteLock. So I will start with some real-time example. So what is ReadWriteLock? So as the name suggests, it is used for high reads and very few writes. So suppose you assume there is an e-commerce application, and thousands of people are viewing the products, and very few are updating the products. Okay, should a user has to wait while viewing the product? Should a user needs to wait? No, user should not wait, because in our application, in order to have a better performance, multiple users should be allowed to read the product simultaneously. But when someone is updating the product, like he is updating the price or some tag, anything or such, then everyone else should wait. The reader should not be able to read the products when someone is updating. So that is how it works. Now let's see what is the read write lock. So as the name suggests, it provides two things. One is read lock and write lock, and the rule should be multiple readers are allowed. Like at a time, multiple readers can view the products, like in our e-commerce application, as I mentioned in the last example. but only one writer is allowed, and if anyone is updating the product, only one writer can update the product, and while he is updating, other readers has to wait. Okay, so that is the rule for read write lock. And yeah, I'll give you one real-time example so that you will get more understanding of this concept. So I think there is a library and 100 students are reading books in the library. You got the point, right? There is a library and some 100 students are reading in the library. So all these 100 students can read the books at the same time. That is possible. But when the librarian is replacing the books on the shelf, when he is replacing the books, then all these 100 students has to wait until he completes that operation. So that is the real time example I can give for read write lock. So let's go to this IDE and check one program. So I'll simple program I have written. So read write lock. So I am creating an object of read write lock. So read write lock is equal to new retrant read write lock. Read write lock is an interface, and this is the implementation retrant to read write lock. And I have a product with the product name is laptop. So when reading a product, you can say lock dot read lock, and you can log this like with you're doing read lock. That means when someone is like multiple threads can access this read method, and in that they can read the product, and finally block I am unlocking the product, because you know, right, even if the exception occurs, the lock should be released. So that's why. And whenever you are updating the product, so whenever you are updating with a new product or changing anything, then I am using a write lock. So whenever you call this write lock method, only one thread can update the product, and the other threads, like these are threads which are reading this read product method, they needs to be wait. They needs to wait until this update product is completed. So I am this product I am replacing with a new product. Like instead of laptop, I am typing a mobile, and in the once the operation is done, I am releasing the lock. Once the lock is released, then all the readers can read the product at the same time. So this is the example of read write lock. And I'll give you some real time examples. So this read write lock concept is used in these things like product catalog, balance, banking balance inquiry, student records, employee directory, configuration, cache, and user profile service. Because there will be thousands of reads, because thousands of people are even anything take the banking balance inquiry, thousands of people are inquiring the, like they were doing the balance inquiry, but very few people are doing the transactions. That's why it is very much suitable for thousands of reads and very few updates, this read write lock. Now let's see what is the difference between synchronized and ReentrantLock. As the name suggests, synchronized is the automatic locking, whereas retrant is the manual locking. So you have the control, so when to lock and when to unlock. Synchronized is less flexible. ReentrantLock is more flexible, and there is no feature of tryLock. But in retrant you have the feature of tryLock, and here there is no fairness. Here it supports fairness lock. uh, this synchronized method we cannot interrupt anything because it is automatic, but ReentrantLock can interrupt a waiting thread by calling the interrupt method. So that is one thing. And after that, what is the difference between ReentrantLock and ReadWriteLock? So ReentrantLock, at a time only one thread can execute this ReentrantLock, but ReadWriteLock, here multiple readers are allowed, but when updating only one writer is allowed. And ReentrantLock is good for updates. This read write lock is best when the reads are frequent. When there are multiple reads, then read write lock is preferred. ReentrantLock is a single lock, whereas read write lock we have two separate locks. One is for read and another one is for write. I think we have come to the end of this video. So we have understood what is the use of ReentrantLock and ReadWriteLock. So ReentrantLock is used as an alternative to the synchronized because it provides the advanced locking features like tryLock, fairness, and interruptible locks. And ReadWriteLock is used when your application has many reads and few writes, so that multiple readers can access the data concurrently while It's ensuring exclusive access for readers. So we have understood these logs, and if you have any doubts, please write it down in the comment section, and thank you so much for watching.